Hello YouTube. Today I'm going to be talking about something I want to talk about for a long time now. It's about something that you might not expect me to be talking about. Today we're going to talk about the STM32 boards, and something that you might not expect anyone to talk about. Hang on, I'm going to get a light in here. It's going to dark in here. There's my cat. So, today I'm going to talk about a few problems with the STMicroelectronics platform and STM32 stuff, and and some secret dark company secrets, and I'm going to tell you how I found a way around it. So let's start at the beginning. STMicroelectronics is a well-known company that makes different types of ARM-based microcontrollers. But there is something that they're trying to hide from us that nobody cares enough to look about. Even if somebody did care, and nobody is going to even listen. They are secretly having viruses in their program. Not one, but two. The first virus is easily detected by Windows Microsoft Defender, but nothing else can pick it up. Usually Microsoft Defender comes up if there is an unrecognized software that is not recognized by Microsoft, or if there is some sort of code software in there that is not very good. And that is, in the case we have is a bad software. But the second virus is a little more detectable by high-end antiviruses. Let's start with finding that first virus. So here we're gonna search STM32 Arduino virus. Now see here, this here is the link you'll want. The first link here, an official forum post that somebody sent. And I don't remember what date it was sent on, but we're gonna go on that link. It's going to ask you to do cookies, and it's going to gray out the screen until you click it. I'm not going to click it because I don't know what software I'll get from them. Now this here is someone, a person, looks like they were posting it a couple years ago. Here's what it is saying on here. So they updated the latest version, basically to put it short, and there's a virus in their program. So this is an official company who has an antivirus that picked up a sketchy program in their official software. A program called RTOSProxy.exe. Now, what is RTOS? It's called Real-Time Operating System. A large community has made a pretty good software that simulates a task management system on lower-end devices. It's kind of hard to set up for certain devices if you know what you're doing, but some other people have set it up, and they can even go as low power as 8-bit controllers. Like the Arduino Nano, the Arduino Uno, the Arduino Mega, stuff like that. It's a pretty good piece of software. But this program, the Cube program, they say they support it when they actually don't support the software. So they're giving you a virus to give you a false sense that they are supporting it. But that's not where it ends. Let's scroll down a little bit here. The person, one of the admins there, employees, is trying to cover up for their scandal with a fake certificate and a fake authenticity setup. This certificate is forged. Why else would it be detected on antiviruses? It's a forged signature. It's fake. And then for some reason they reposted it for some reason. They say the utility is executed during the debug flow to enable some RTOS features. They don't support RTOS on this program. They're lying about it. But it doesn't end at viruses. A bunch of people have made a Reddit post on Reddit saying that they're trying to find an alternative for the software. Not because of viruses, but because it's not that well made. let me put in here STM32 alternatives. STM32 QProg alternatives. Okay, it's not going to show up unless I put the word Reddit in the search. So we do that. And here, it is the first link you want right here. And no, I don't want notifications, thank you. So here, these are a bunch of people that are having trouble working with their software because it's badly designed. Not because of viruses, but because it's badly designed. But yes, it has viruses, but they don't know about it. So to talk about finding alternatives for their badly designed software, let's do the entire discussion, shall we? I would go over this all day, but it will take a lot of time. I will leave links in the description to the evidence if I remember to put them there, so you can read them yourself. And there is like a bunch of like different people who are trying to find alternatives for the software. So yeah, we're looking at some pretty bad stuff here, I think. But what if I told you there is actually a way around this software, so you don't need to download it? It is with the Arduino program. STMicroelectronics has released an Arduino driver used to put in the Arduino software, so you can use it there. But you still need to acquire this virus-infected software to even upload to the controller. But I'm going to tell you a way around that. There was an STM32 Arduino project by a person named Roger Clark that came before the official one. And when the official one came out, the development on the Roger Clark one has seemed to stop. So I'm going to tell you how you can incorporate this into the official STM32 drivers with little to no hassle. This is the software hack that is necessary to be able to use these safe if I'm on the computer. So we want to go to GitHub. It automatically signed me out on here because I haven't been on here for a long time. But let's search STM32 Arduino. Then you want this one here by Roger Clark Melbourne, Arduino STM32. In here is a software driver that you are going to have to need. But before I do that, I'm going to open Arduino and erase my work that I've done so far. If you update your board packages, it will reset all the files in there. So I'm going to reset all the work I did just for the sake of this video. I kept it outdated just for this purpose. So I'm gonna go into my board manager here and upgrade the file. I kept it downgraded for this purpose. When it hurries up and loads, then we just this might take a while to actually get this. It might take a while to get it updated though. So I'm gonna sit here and chat a little bit, I guess, while I'm waiting for it to install. So, there are plenty of alternatives to use from these boards. These are there are like plenty of alternatives in this box. Like most of the ones in this box are actually usable. Either 8-bit or 32-bit, there's plenty of alternatives for these type of boards. Since I had nothing but trouble with getting these types of boards to work. They're not that good, trust me. The first one I got was an STM32 F407. It would not even properly boot, and it was giving my computer suspicious signals, which causes ghost USB flash drives to appear. I had two in the same port. So let me ask you this. How would you put two USB flash drives in the exact same port without a USB splitter? Because I do not have a splitter. I cannot put more than one USB flash drive in one port. But it should give an error message, or at least have some bug if I unplug it without ejecting it. But this STM board, not this one here, it's a different one I used to have. It was causing my computer to have software glitches just by plugging it in. Regardless of how I configured the wires and the boot jumpers and whatnot, it was just a big hassle. It came with some wires and a USB cable, but that was the only two things that were actually good out of it. $3 of value out of a piece of crap board that doesn't work. Eventually, later, I have found this. It was also a piece of crap board that doesn't work. But they did the boot system a little differently, which is a little more efficient actually, by using buttons instead of crappy jumpers. I had trouble with this too, until I found a software hack. Then I found this one here. This one is a lifesaver. It had this bare converter chip on it. It's still very useless to me though. But it came with a cable, and that's cool. Now, when this thing hurries, I'm going to finish this installing, which it might take ages to do so. Maybe like half an hour, I don't know. So yeah, they have like a lot of boards, and STM boards don't really seem that good. They're very hard to program, they're not easy to work with like usual boards are. I have covered this in a previous video about their program methods and how they're limited by certain things. You cannot program these through the straight USB port. You can only program them through a JTAG adapter, and if you need to, a serial FTDI adapter. FTDI adapters are a lot easier to use and better to work with. Now this here is done installing. I'll wait for the program to load me closing it, and then I'll close the program. Okay, now back to this GitHub page from Roger Clark. Here is how you can hack the Arduino software to make it so you can use the driver from here and not the virus software. Go into the right here. I'll leave links to this in the description. You go to code, you push download zip. I have already downloaded it, but I will still show you. You go into your file explorer and you go to downloads. You find your zip file and left click it once. You will see this up here, extract compressed folder tools. You click on this, then you go to the right and click extract all. Select your file destination and click extract. It will open on itself on completion unless you have the checkbox disabled. This here is not the library, this is a different library, but it's the same principle. It's a different software, but it's basically the same principle. Now we can close Google Chrome or whatever web browser you have decided to use. Any web browser should work, as long as you can download the file and save it. Now go to where you have your Roger Clark STM32 drivers. I saved it in a folder on the desktop. All the files will be put into a folder named after the repository and the word master after it. You open that, and this here is where you'll find your drivers under tools. This software supports different operating systems including Linux, Mac, and Windows. I am currently using Windows, so I will go to the Win tab, which is Windows. Now, we have to open up another folder. You can only find this folder if you search it in the search bar. You will search %appdata%. You can only find this folder by searching it. You click on right here, like this. It will automatically take you to the roaming folder. You have to go right here and click the app data right here. Then you want to go to local like this. Go to Arduino 15. It might say Arduino 17 if you're using Arduino 2.0, but I'm using the legacy Arduino, so I'm Arduino 15. Then you click packages. You click on packages. Then you, let me just get rid of the toolbar tab because it came up on its own when I click the extract. find the folder STMicroelectronics. If you have already downloaded the STM32 files already, go to hardware. Wait, no, don't go to yet. You want to go, when you're in the folder, go to tools, STM32 tools, the version number, then you click Win, which is Windows. And now, what you want to do is go back to the folder where the Roger Clark file is in. You want to find two files. You want to copy two files, serialupload.bat and STM32flash.exe. Right click and click copy. You go back into the STMicroelectronics tools folder and go somewhere away from the other files. Right click and press paste. The new tools will be up in here. Next step we want to do is go to change the board settings to support this. You want to go back on the Roger Clark drivers, go into STM32F1, then go to board.txt. You want to also open out the board.txt in the official Arduino STM32 driver too. You gotta go back, go to hardware, STM32, the version number, right here, board.txt. We go back to the one we found from Roger Clark, and we scroll down until we find the upload methods for the STM32 F1 series controllers. It's probably better to search it though. We found here, upload methods. We scroll down a little more until we find the serial upload method. It might take me a little while to find it though. Actually, I have a better way to do this. Go to Edit, Find, type in Serial, enable Matched Case. Then it should be right here. Here's what you want to do. You want to copy these three lines right here below the first one. I had word wrap enabled, so I have to disable word wrap because I forgot to disable word wrap last time I had it on. And now, once you have them highlighted, right click, click copy. Or you can hold Control and press the keyboard C as in cat. Now we're going to go over to the STMicroelectronics boards. You want to go into Find, Edit and Find, search for Gen F1, and make sure Match Case is unselected. Click Find Next. You will find the generic F1 series controller, the STM32 F1. You want to go down here and change that to say Serial. Put Find Next. And then click it a second time. Down here is the upload methods. First you want to do, this says STM32Q programmer serial. What you want to do is just make it say serial with the parentheses and the word STM32Q programmer. Oops, I didn't want to remove the equal sign. Now you want to highlight the three lines below and replace them with the line we just copied. Once your lines are highlighted, right click and press paste. It will replace. Oh, for some reason that got for some reason, like, the lining on it is being all... Oh, wait, that's why. For some reason, word wrap got enabled again for some reason. That's weird. I thought I disabled word wrap. Okay, I don't know what's going on. I disabled word wrap and it turned itself back on for some reason. Maybe I gotta close it to save it. Okay, hang on just a few minutes, please. So it should look something like this, but there's one thing we gotta do first. These names here do not match. You want to copy this word here, Gen F1, and replace these other three lines right here. You can right click and click paste, or hold Control and press V as in Victor. Now, copy these three lines here that we just edited. Now, because of how this software is set up, you have to do this method for every single board that you're using. I will be using STM32 F1 and F4 since those are the ones I currently have. The ones I currently own. We'll push find, then put Gen F4. Like this. Just find next, then replace that with serial. Click find next 2 times. Here's the exact same thing we have to do. Change this to just say serial. Replace the free line with the line we just copied. Now here is another naming mismatch. We have to replace the one with number 4, like shown up here, like this. You should see them like this. Make sure you do this for every single file, every single board type you need to use it on. Then make sure you save your file. Next, we're going to go into platform.txt. Let's start off the run in the Roger Clark driver, platform.txt. This is where you actually tell it when to use the upload tool. We go into our official drivers and open the same file, platform.txt. You may have to scroll down a little bit. Now, go into the platform.txt from the Roger Clark drivers. Have to scroll down here past the compile settings until we find uploader tools. Make sure word wrap is disabled or this might come up a little funny. Here's what you want to do. This part here tells you what extra stuff you need to do to make it work in serial mode. Deserial the serial parameters. Copy from this comment down to the bottom of the last line. Now, since you have those lines copied, go over into the STM32 Arduino drivers and scroll down. We'll find the uploader tool. Here's where it says STM32 Q Programmer Upload. This part here is optional, but you want to replace this word with the word serial. Like so. Now you want to comment out all of these by putting a hashtag in front of them. It should look like this. Now what you want to do is go over here so you can go down to the next line. Hit enter 2 times. Then you want to paste in what we just copied from the Roger Clark drivers. But we're not done yet. Here we want to take out the drivers that we're not using. Since I'm using Windows, I will remove this extra one right here that says Mac OS Serial Uploader. You can hold left click right here and drag down to get all of them, then press backspace, and we'll make it instantly do it. Then you want to delete these 3 lines right here for Mac, Linux, and Linux 64. Now we're left with this, but there's one more thing we need to do. We have to change the path that the driver tool is located. Scroll up a little bit, and you want to go to here, with the path for the original uploader tool is, copy from this period tools to STM32 tools in the other period. Only include the period in the middle, not the other two. Now, we'll go right here, where it says runtime.hardware.path. Remove hardware and paste in that stuff we just copied. And now, we want to remove, right here where it says /tool/win, remove the tool slash. Make sure you save your folder. You can delete the other stuff, you can delete this other stuff here if you want to. Now, since that is saved, we want to go into Arduino. Open the Arduino program. If it were to hurry up and load. And now that it's open, we want to open the basic Blink example. I have made a modification of the Blink example, so I'm going to open my modified version. It's still the same thing, it's just a little more simpler and adds an extra parameter for the LED setting. Make sure your LED pin is set to LED_ built in. Then you want to select your board. From your STM32 drivers, we're going to start with the F1. Oops. Start with STM32 F1 series. Like this. Now we go to Tools, select our part type. I am using the blue pill with F103CB. It's just the F103C8 with double the flash memory. That's about it. And now we want to change our upload method. This here is serial. It would say STM32Q programmer serial if we didn't do this modification. Select serial. Keep all your other settings, the default settings. If you want to optimize the code, you can, but that's optional. And now, we're going to do a pre-compile verification to make sure that it works. I'm going to prepare my board while it's compiling. Even though this one has a STDI adapter built onto it, it won't automatically enter program mode. Over here is the boot select jumper you need to connect. Your board may be different. Connect boot 1 to 3.3 volts. Connect boot 0 to ground. Actually, wait, I had those backwards. Connect boot 0 to 3.3 volt. Connect boot 1 to ground. Sorry, I got those little backwards actually. Sorry for that, okay. Now, this does not have a boot 1 on it. It just has a boot 0, but it's still already connected to ground internally. I will jump a wire between boot 0 and 3 volt. You should have either a little tiny jumper or a wire on this connecting your pins together. Now I'm going to wait for it to finish compiling. Now, since it paused successfully, we'll plug in our controller. And now, make sure your port is selected. My board uses COM3, yours may be different. Once your port is selected, and your serial port is and your serial upload is collected, hit upload and just wait. The controller is plugged in right there in program mode. You would see the LED start flashing at the speed you have it set to if you change the delays. And we're gonna wait for it to load. You will see a bunch of numbers appear down here that cycle up as it uploads, telling you that it's actually writing to the controller. It will also automatically reset the controller too. So you see that? If you saw that, then you succeeded. Now the board is flashing. It will automatically exit program mode once it's running. From then, you want to make sure, if you unplug, you want to make sure your boot 0 is connected to the ground. So now it's connected to the ground. It will make sure it activates stably every time you power it on. Let's go see what the readout said. Let's go read the readout from the uploader tool. There is the memory usage. There is a version number. There is a Google Docs code on here. Note that this Google Docs is no longer available. So it's not available anymore. It's information about the programmer, the serial port, different controller things. Note that your controller output type may not be accurate on some devices. This is how much RAM it has, this is how much flash it has, and some other things. Although for different chips it may come out differently for like the F4 controllers. There is a write process and there is a start process. Let's do the same thing for STM32 F4 boards. Go on your board and your tool selection and select generic STM32 F4 series. We will do the same thing that we did before. Select your part number. I am using a Blackpell STM32 F401cc. That's the one I have. We will select our upload port to be serial as we did before, like this. Now, this controller, the bootloader on this is broken, so it's actually not broken, it's actually just badly designed. It's poor design on the software and stuff. So the USB port on here actually does not give you a port. So it does not work. Drivers or not, it does not work. You want to attach an FTDI adapter to your board. I have a wiring chart that I made for different types of boards on here. Note that for the F103s and F401s, it is the same wiring. You get your FTDI adapter, and make sure you have one that has a logic level selected on it, which is right here, right there. Set it to 3.3 volt logic. Make sure your supply voltage is set to the right pin you connect on the controller. 5 volt to 5 volt or 3 volt to 3 volt. Do not connect both at the same time and do not get them mixed up. Now make sure your pins are set there would be, sorry for the focus not being good. So the 3 volt and 5 volt, 3 volt and ground right there. Then your transmit line will go to pin A10. Your receive line will go to pin A9. And that is a wiring you need to do. Go back into our, go back into Arduino. When I plug in your board, let me just get my charging cable around over here. Now plug in your board. And now we have to manually put it in program mode. This one has 2 buttons on it. What you want to do is hold down boot 0 and tap reset. And keep holding the boot 0 button for about a second, and then you can release it. Now the board is in program mode. Since this converter uses the same driver chip as the other one does, But still, if you're using a different one, make sure your port is selected and your upload method is set to serial. Now, this upload tool has a little delay when working with F4 boards, so just wait patiently and eventually it'll begin uploading. We'll start doing that right now. Let's wait for it to compile and upload. Sorry if it's taking too long. I'm not able to edit the video to make it faster. So if you want to, you may skip ahead to get past this part if you want to. Since I'm not able to edit them right now, since I don't have my editing software, I don't feel like downloading it again because of a recent hacker attack. That was like a couple years ago or something. Last year sometime or 2 years ago. And see, it is going to take a little delay, but eventually it will begin its process normally. See, it started uploading, and now it automatically resets. You have the blank code on this controller now. Let's check the readouts again to see what because it gives the process information. Now, just so you know, the device ID, RAM, and flash usage may not be accurate with some controllers, as it may give you the wrong values. It may be the controller, it may be the upload tool, I'm not really sure on that. And then it has completed its process and it's all done to go. You can unplug your board and your code will stay on there as long as you don't upload it again. Here's the cool thing about these type of boards. Even if you were to accidentally put it in program mode. Let me put it in program mode now to show you. So even if you accidentally put it in program mode, just make sure your boot 0 is hit the ground and boot 1 and then reset it and it comes back to life exactly how we had it. Some people may think the code is entirely erased, but it's actually not. It's just halted until a command is sent to upload it or reboot it. Now, theoretically, this upload tool may work for other types of controllers, but I am not able to test that right now since I do not own other controllers, and I currently don't have any plans to get more since I don't like those type of boards. If this software does not work on other chipsets, for example, the F0, the F3, F2, and H7s and F7s, which are different types of STM32 boards. If it does not work, put it in the comments, and one day I will see if I can make my own uploader tool that supports them all. It might take several years though, but eventually I'll get around to it and get it finished. I hope you enjoyed this little tutorial and exposing of factory company secrets. And I will see you next time. I have plans to make alternatives to these type of boards that are a lot more easier to program and a lot more better in quality. But anyway, I will see you next time, and ZenCraft21 out. Goodbye.